Apologies for the delay if you can see me or hear me. Apologies for the delay if you can see me or hear me. I had to click on motorcycles for about 5 minutes. Gotta love modern internet. Look, man, I'm not sure if I'm a robot or not, honestly, at this point. Where do I pop out chat? Oh, wow, I'm streaming. That's my favorite streamer. How do I pop out chat? Here we are. Hey. Sorry for the delay. I should have had this all running beforehand. I forgot. Well, not really forgot, I guess. I just had to click on motorcycles. Usually I do the setup first. Where is YouTube? We had a YouTube channel last time, I believe. I had this very exciting journey of me moving windows about. Don't we love this? Today we're doing storing UTF-8 encoded text with strings. UTF-8 is the best F8. I don't know what I'm talking about, man. Seriously though, UTF-8 makes the most sense. It can store everything with the smallest footprint. Though a lot of people might argue, it doesn't really matter. Alright, here we go. Let's pop out this chat too. Yeah. Never remember. I always redirect to YouTube. I don't trust their tracking stuff. For today, it's fine. We got extra protection. Alright, we're on Restream. We are ready to go. Been messing around with the tiling for this thing. Got these things split up. Should be quicker to set up. By quicker, I mean it's been took me a minute to get it all set up. That's brilliant, isn't it? That's real quick, man. Right, I'm gonna wait a little bit longer to see if anybody joins in, but then I'm just gonna start reading this. Honestly, if you weren't here to read, this is probably not going to be too important. This is pretty simple. It's just storing UTF-8 encoded text with strings. Strings are quite meaningful and long-term, but really, I don't think it's going to go into, like, too big of a deal. Pretty long section. I guess I might be wrong. What? Oh, we're doing hash maps next. I'm excited for that. Very rare that a hash map is useful, but I always like it. They make me happy. Alright, let's check on my audio. This is a collection of words. Can you hear me? Look at that. Looks good. A little bit of a delay, but a lot better than normal. Great stuff. Watching a guy earlier on today, just trying to see how things were, see how they set stuff up. The delay was massive. Well, I guess it is just streaming from me to the closest Twitch-based server back to me. Probably a lot more for anybody else here. Or maybe they just have an inherent delay. Maybe they put something on there. Still gonna wait for about 5 minutes for this to start. If you're watching this afterwards, just skip. I was thinking of editing these down a little bit, getting it to a point where somebody could actually watch this and gain a little bit of knowledge, maybe a little bit of joy even. One of those things you put on the back burner and never really get done. Just a moment for those watching, I'm gonna drink tea. We have 3 viewers. I wonder who that is. I think it might be a ghost. Jay Jader. Hi, thank you. I'm glad to see you in here. Yeah, no worries. Probably quite late or quite early for you. Not at all a problem. Thank you for jumping in. Just waiting until the 7:40 mark, and then I'm gonna start reading. Getting into the real interesting stuff today. UTF-8 encode. There we go. I've still lost my hat. I can't find it. Hey, Sorbet. Glad to see you in here. Alright, the entire crew's here, I guess. One person. You know what? I'm not at all sad. I thought that I'd be alone here for like 5 sessions straight at a point. Alright. I'm personally just going to start. Grayed out words, as always. I'm going to start out with this. Just start talking about storing UTF-8 encoded text with strings. We talked about strings in Chapter 4, but we'll look at them more in depth now. Neurostations commonly get stuck on strings for a combination of 3 reasons. Rust propensity for exposing possible errors, strings being more complicated data structures than many programmers give them credit for, and UTF-8. I love UTF-8. These factors combine in a way that can seem difficult when you're coming from other programming languages. We discuss strings in the context of collections because strings are implemented as a collection of bytes, or char characters, plus some methods to provide useful functionality when those bytes are interpreted as text. In this section, we'll talk about the operations on strings that every collection type has, such as creating, updating, and reading. We'll also discuss the way in which strings is different from the other collections, namely how indexing into a string is complicated by the differences between how people and computers interpret string data. Alright. What is a string? We'll first define what we mean by the term string. To be honest, I've never really looked into why it's called a string as like an idea. Rust has only one string type in the core language, which is the string slice. Str that is usually seen in its borrowed form, borrow str. In Chapter 4, Rust has only one string type in the core language, which is the string slice. So string isn't actually a thing. Okay. I'm pretty sure I've seen people put string as a type in. Chapter 4, we talked about string slices, which are references to some UTF-8 encoded string data stored elsewhere. String literals, for example, are stored in the program's binary and are therefore string slices. Okay. The string type, which is provided by Rust standard library rather than coded into the core language. Oh, I see. Okay, that's what it meant. It's not in the core language, it's just in the preamble, the what do they call it? Something about like pretext? The thing that comes before all code that brings in certain things which may not actually be needed in the entirety. There's a global, mutable, own UTF-8 encoded string type. When Rustaceans refer to strings in Rust, they might be referring to either string or the string slice types, not just one of those types. Although this section is largely about string. Both types are used heavily in Rust's standard library. Both string and string slices are UTF-8 encoded. Even on Windows? I mean, really good if it's on Windows. Like, what if we pass in something from Windows that is UTF-16 encoded? Is it converted to UTF-8 encoding? I mean, that really wouldn't matter. The same thing in the end. I hope so. Can we bring in UTF-16 or 32? Just utilize UTF-16 and 32 as they are built? A lot of questions that I'm not going to answer. Sorry. And apologies again, I don't have my hat. It's gone. Hat's gone. I'm upset about that. My hair is terrible. Yeah, str and string types were kind of confusing to me. Someone explained that str is more like a list of char, and string has more stuff in it. Yeah, I guess that probably works, yeah. My understanding was just that str was just a subsection of it, a slice of it saying like, hey, it's just this specific point. Well, my hands can't be seen here. But string is like the entire context with more wrapping around it. So I guess that arcs on to what you're saying. I guess they are right when they say it's a bit more complicated than what the average person might think. Creating a new string. Many of the same operations available with vec are also available with string as well, but the string is actually implemented as a wrapper around a vector of bytes with some extra guarantees, restrictions, and capabilities. An example of a function that works the same way with vec and string is the new function to create an instance. Yep, shown in listing 811. Let mutable s equals string, new, creating a new empty string. This line creates a new empty string called s, which we can then load data into. Often, we'll have some initial data that we want to start the string with. For that, we use the toString method, which is available on any type that implements the display trait, as string literals do. Listing 8-12 shows two examples. We have let data equal, and then a string literal. We have let s equal data.toString. The method also works on literal directly. Oh, okay, so we just have the literal here, toString. That is good to know. So I don't honestly see why the compiler can't just tell that we have a string literal. I want to make, well, I guess this is s equals the literal, not something which is of the string type. Never mind on that. That does make sense. Using the toString method to create a string from a string literal. This code creates a string containing initial contents. And we can also use the function string from to create a string from string literal. To create a string from a string literal. Okay, sorry. The code in listing 813 is equivalent to the code from listing 812 that uses toString. A string from, and then we pass in something. In this case, we pass in initial contents. Right. Because strings are used for so many things, we can use many different generic APIs for strings, providing us with a lot of options. Oh god, I can't talk. Because strings are used for so many things, we can use many different generic. I wonder what the difference is between running a string to turning str into string with. Sorry, what? I wonder what's the difference between turning str into string with into instead of toString or string from. Where was into from? I don't honestly remember looking at into. I'm sorry. Did we learn that? Primitive type here. Is the one you know. I don't think I've remembered that. Clone into. Oh, we didn't learn that. Okay. Can't find it in the docs either, which is very weird. I thought I'd be able to. I'd really like to see that. I wonder what the difference is myself. Right, we have into string. Is this what you mean? Is into string what you mean, or like is there an actual thing just called into on an str? Sorry. Oh my lord, there's a lot of stuff here. Or were you talking about the string itself? Oh, oh, that's on the actual module string, not a string. Sorry, what is it called? not the str. Instead of an str, you're talking about a string with the string type. Okay. I don't actually know what the into does at all. I'd love to know the answer myself too. But it looks like this might be a bit more hard to figure out myself. That is a good question, though. Thank you for bringing that up. We can also use the function string from to create a string from string literal. The code in this listing. Oh, where were we? I believe we were here. Because strings are used, because strings are used for so many things, we can use many different generic APIs for strings, providing us with a lot of options. Some of them seem redundant, but they all have their place. In this case, string from and toString do the same thing. Which you choose is a matter of style and readability. Remember that strings are UTF-8 encoded, so we can include any properly encoded data in them, as shown in listing 8-14. Okay, yeah, we can put anything, including emojis in there. Storing greetings in different languages. All of these are valid string input. Updating a string. A string can grow in size and its contents can change, just like the contents of a fact. If you push more data into it, just like the contents of a vec, if you push more data into it, it'll copy it over and then destroy the original. In addition, you can conveniently use the plus operator or the format macro to concatenate string value, appending a string with the push string and push. We can grow a string by using the push string method to append a string slice, as shown in listing 8.15. Let mutable s equal string from foo. S.push str bar. After these two lines, s will contain foo bar. Push string method takes a string slice because we don't necessarily want to take ownership of the parameter. For example, the code in listing 8.16, we want to be able to use s2 after appending its contents to s1. Let mutable s1. String from foo. Let s2 equal bar. Push in bar to make it foo bar. s2 is foo bar. Using a string slice after appending its contents to a string. If the push string method took ownership of s2, we wouldn't be able to do it. That would be bad. Push method takes a single character as a parameter and adds it to the string. Listing 8.17 adds the letter I to a string and then pushes it into an L. Yep, that's LO and then plus L. Why would you want that? I really don't understand why you'd ever want to just push one single letter and only ever one single letter and have some error if it's more than that. Because this original one would do the same thing if you just put in one letter. I don't see the purpose for that. There's probably a purpose I'm not looking into, honestly. Combination with the plus or format macro. I'm sorry, this is incredibly boring. There's not a lot of new information here, sadly, so far. Often you'll want to combine two existing strings. One way to do so is to use the plus operator. As shown in listing 8.18. We have s1, string from hello, s2, string from world. Nope. S1 has been moved here and can no longer be used. Okay, that's a good thing to know. So, what about S2? Oh, and reference S2. Okay, so we're creating a slice here, or we're using simply the reference. So S1 is currently no longer being owned. It's not usable. But S2 is usable, I guess? Does it state that anywhere? Run this code. That's meaningless. Okay, fine, whatever. Using the plus operator to combine two string values into a new string value. The string S3 contains hello world. The reason S1 is no longer valid after the addition, and the reason we use a reference in S2 has to do with the signature of the method that's called when we use the plus operator. The plus operator uses the add method, whose signature looks something like this. Add self and a string slice. Outputs a string. The standard library, so if you want to use the plus operator, are you always going to have to do that? I assume so, because it wants to take in a reference string. Or a reference str. String slice. In the standard library, you'll see add defined using generics as associated types. Here we substituted in concrete types, which is what happens when we call this method with a string value. We'll discuss generics in Chapter 10, not that far from now. The signature gives us clues we need to understand the tricky bits of the plus operator. First, S2 has an at, meaning we're adding a reference of the second, means that we're adding a reference of the second string to the first string. This is because of the s parameter in the add function. We can only add a reference string slice to a string. We can't add two string values together. But wait, the type of reference S2 and reference string is not reference string slice, as specified in the second parameter of add. So why does listing 818 compile? I believe that it automatically converts, right? The reason we're able to use reference S2 in the call to add is that the compiler can coerce the reference string argument into a reference string slice. Yep. When we call the add method, Rust uses a deref coercion. Here turns reference S2 into reference S2 array of bytes including the entirety, which is a string slice. We'll discuss deref coercion in more depth in Chapter 15, because add does not take ownership of the s parameter. S2 will still be a valid string after this operation. So yeah, when we put in one string plus another string, the first string no longer has ownership, that is consumed and likely not able to be used anywhere else. I don't see when it should be brought back. But S2, the second string, stays there. It's perfectly fine. You can still use it. That's good to know. That just seems like a fuck gun. That's a massive fuck gun. Thank you for this, Rust. Second, we can see in the signature that add takes ownership of self, because self does not have an ampersand. This means S1 in listing 818 will be moved into the add call and will no longer be valid after that. So although let S3 equals S1 plus reference S2 looks like it will copy both strings and create a new one, this statement does the following. Add takes ownership of S1. It appends a copy of the contents of S2 to S1, and then returns back ownership of S1. So this does mutate the original string. S1 has enough capacity for S2, and no memory allocation occurred. However, if S1 does not have enough capacity for S2, then S1 will internally make a larger memory allocation to fit both strings. It'll destroy the original, it'll copy over the original, destroy it, and then pass back a reference to the new one. If we need to concatenate multiple strings, we have the behavior of the plus operator gets unwieldy. So we have string from tic-tac-toe. Okay, so we have the original string plus a string literal plus reference string plus string literal plus reference S3. At this point, S will be tic-tac-toe. All of the plus and double quote character. With all of the plus and double quote character, it is difficult to see what's going on. For more complicated string combining, we can instead use the format macro. A bit of this is the poor writing, a bit of this is me. I just can't read today. That's good to know. Let S1 equals string from tic, tac, and toe, let format, and then we just use a string interpolation or whatever it's called. I never remember the name for this. Put it all together. And the brackets will be our data, or our variable. Right, I'm just personally never going to use the pluses. I don't know about anyone else. I think I'm going to ignore that you can use this plus, and anytime I see it, I'm going to run away screaming like a little cow. It's at least not going to be written in my own code. I see no reason to do this weird, obscured thing where it takes ownership of one of the three different pieces, but it's not explicit. I see no reasoning for that. Does format do the same thing? The format macro works like printline, but instead of printing the output to the screen, it returns a string with contents. The version of the code using format is much easier to read. The code generated by the format macro uses references, so that this call doesn't take ownership of any of its parameters. Okay. I'll just be using this, even for like two things added together. Well, no, I probably won't. I'll just be using something else. I'll use push string, something like that, because I don't want ownership just to be taken, consumed. There's no reason for that. What is the difference between using a plus b and a.pushString b to concatenate to a string? Push string consumes ownership b? Well, plus does not. I think that might be true. Plus consumes ownership of a, while push string does not. No, that's true. The plus operator does consume ownership of a. Push string does not consume ownership of a. A still maintains ownership of a. Push string is more efficient at runtime. There's no difference. They're aliases for the same functionality. Nope, I think this to be correct. Plus does consume ownership of a. It is incredibly dumb. And push string does not consume ownership of a, because there's no new variable here. It never passes anything back. What is the maximum number of times a heap allocation occur in this program? Write your answer in digits, e.g. 0 or 1. So we have tick, tack, and so we have this. We have S1. Right, so heap allocations. We've allocated tick, tack, and so that's 3 separate there. We have S1 plus this, which will copy over. S4, destroying this, plus this reference. I don't think that allocates. Maybe it does? No, I think it does. Yeah. Because this needs to be contiguous. It needs to be continual. It needs to be forever. That's 5. And then because again, this is just a string literal that we're pushing into the top of this. That's 6. 7. I believe that is 7. The maximum allocations, I believe, is 7. Got any issue with that? I don't. Unless you think that's different, it's possible to be different. I might be missing something. Just to go through this again, we have tick, tack, and toe. Then we have S1 plus a string literal, which needs to allocate more, so that's 4. This, which needs to allocate a new thing for S1. 5. Wait, what? 1, 2, 3, 4, 5, 6, 7. Does str go into the heap? I don't know. A string slice? I believe that a string slice is stored in regular stack memory, but the string that it points to is stored in heap. So a string slice, str, needs a heap memory string, a full-on like tick, for it to point to. So the string slice is in a regular stack, but what it points to needs to be in heap. That is my belief. Don't quote me on that. This is my understanding so far, though. On top of that, though, here we are not using a string slice. We're not using a string slice in any of these. S1 will not be a string slice. Plus operator returns a string. So S1 needs to be replaced by a new piece of memory. The question, I guess, here is, does the 3 plus operator, does that allocate continually? Does that go like allocation here, allocation here, allocation here, and allocation here? Or does it make all of this work here and then allocate once to a new string? But I guess to really answer your question, I believe that STRs will still store heap memory. When you create an STR, there will be heap memory, but the string slice itself will be in stack. Right, personally, I'm going to answer 7, but I think that this could be 4 if this operator does some weird thing. You cheated a little bit, and it seems like STR could be in the heap, yeah? Cheat all you want if it helps me out. Thank you. Right, I'm going to answer 7, but I wouldn't be surprised if it's 4, because the plus operator, the compiler sees that there's 1, 2, 3 pluses, and then I'm going to go with this. 2 out of 2 correctly. I was correct. Okay. Right, context. Well, string takes a mutable self, while plus takes self, so a mutable reference to self, while plus takes self, so plus consumes ownership and push string does not. No. Secondary, 1 allocation for each call to string from, and 1 allocation for each time plus is called. Good to know. You got it correct, thanks. Indexing into a string. In many other programming languages, accessing individual characters in a string by referencing them accessing individual characters in a string by referencing them by index is a valid and common operation. However, if you try to access parts of a string using indexing syntax in Rust, you'll get an error. Consider the invalid code in listing 8:19. We have let string s equal string from hello, let h equal s1 0. Attempted to use indexing syntax with the string. Why? Why isn't this allowed? Why can we not just get h here? I think that works even in like C. Because a string is just an array of star characters. Why have they added so much complexity to a string that this will no longer work? The error and the note tell the story. Let's read the note. Compiling, the type string cannot be indexed by integer. A string cannot be indexed by integer. Trait index integer is not implemented for string. Following other types implement the trait index. We have string as index range from usize, string as index range full. Okay, so it's just asking us for a range, or a standard ops range usize. So these are all of the things that strings can be indexed as. So instead of like every other language where you can just put in an I32, you have to put in some weird range even if you just want the 0th element, first element. Sure. Rust strings don't support indexing. Oh, okay, I guess this is a lie. But why not? To answer the question, we need to discuss how Rust stores strings in memory. A string is a wrapper over vec u8. Yes, that should mean that we can just get the first one. Let's look at some of our properly encoded UTF-8 example strings from listing 8:14. First, this one. Let hello, string from hola, or ola. In this case, length will be 4. It means the vector storing the string is 4 bytes long. Each of those letters takes 1 byte when encoded in UTF-8. Following line, however, might surprise you. Note that this string begins with the Cyrillic letter Z, which is not the Arabic number 3. Correct, so that will be in UTF-8, but it'll be a 2-bit string. Asked how long the string is, you might say 12. No, because there's Cyrillic in here. In fact, Rust's answer is 24. Yes, because Cyrillic was within the 16 range, so each char character needs to be 2 separate bits wide. However, you can put some structure around that in order to still get each number correctly. That's what every other language does. I'm pretty sure including C. In fact, Rust's answer is 24. That's the number of bytes it takes to encode this in UTF-8. Because each Unicode scalar value, this thing that pops up, and that string takes 2 bytes of storage. Therefore, an index into the string's bytes will not always correlate to a valid Unicode scalar value. To demonstrate, consider this invalid Rust code. Let hello equal this, and answer equal reference hello 0. We already know that answer will not be 3. The first letter, when encoded in UTF-8, the first byte of 3 is 208. The second is 151. This would be ASCII 208. So it would seem that answer should be in fact 208, but 208 is not a valid character on its own. Returning 208 is likely not what a user would want if they asked for the first letter of this string. However, that's the only data that Rust has at byte index 0. Users generally don't want the byte value returned, even if the string contains only Latin letters. If reference hello 0 were valid code that returned the byte value, it would return 104, not H. Right, but what if, hear me out, we had just a list of references to char characters which could grow and shrink with the values being held? That would be very useful, wouldn't it? The answer to that is that to avoid returning an unexpected variable and causing bugs that might not be discovered immediately, Rust doesn't compile this code at all and prevents misunderstandings early in the development process. Bytes and scalar values and grapheme clusters, oh my. Another point about UTF-8 is that there are actually 3 relevant ways to look at strings from Rust perspective: as bytes, as scalar values, and grapheme clusters. I don't know what a grapheme is. What is it to grapheme? Okay. A grapheme. I'm okay with that. Or not, I guess. What is a grapheme? Why is this working like this? I hate this. Come on. Let's go in. Let's go in. Accept the risk and continue. A grapheme is the smallest functional unit of a writing system. The word grapheme is derived from ancient Greek, right? And I don't think this is really useful. As always, developers are trash. The closest thing to what we have is what we call letters. Okay, if you look at the Hindi word, this Hindi word, written in the Devanagari script, it is stored as a vector of U8 values that looks like this. Okay? Has 18 bytes, and is how computers ultimately store this data. We look at them as Unicode scalar values, which are what Rust calls char types. Bytes look like this. Okay. There are 6 char values here. The 4th and 6th letters are not letters. They're diacritics that don't make sense on their own. Finally, if we look at them as grapheme clusters, we'd get what a person would call the 4 letters that make up the Hindi word. Okay. Rust provides different ways of interpreting the raw string data that computers store so that each program can choose to interpret its needs. Can choose the interpretation it needs, no matter what human language the data is in. The final reason Rust doesn't allow us to linguistic parentheses. I don't understand what you're talking about. That's what a grapheme cluster is? Sorry, with the delay, it can be kind of weird, where people start on and off things. This is some beautiful script, however, I have to say. Seriously, the words in these languages are beautiful. An art form in and of itself. Honestly, I could not write in Hindi. Or sorry, not in Hindi, oh yeah, I guess in Hindi. Absolutely gorgeous. Alright. A final reason Rust doesn't allow us to index a little linguistic segment. Yeah, I guess so. That's just a little bit of knowledge based on linguistics. I guess it is quite important for us to know if we try and do different languages in our programs. I used to do a little bit of French in the programs that I wrote, and I can understand how hard that can be to make work. A final reason Rust doesn't allow us to index into string to get a character is that indexing operations are expected to always take constant time. 0, 1. But it isn't possible to guarantee that performance with a string, because Rust would have to walk through the contents from the beginning to the index to determine how many valid characters there were. Hello? Oh, I do not speak French, to be entirely clear. I was faking it the entire time. I don't think they ever found out. Indexing into a string is often a bad idea, because it's not clear what the return type of the string indexing operation should be. A byte value, a character, a grapheme cluster, or a string slice. If you need to use indices to create string slices, if you really need to use indices to create string slices, therefore, Rust asks you to be more specific. Rather than indexing using square brackets with a single number, you can use square brackets with a range to create a string slice containing particular bytes. Right, 0 to 4 would be the first 2 letters, because Cyrillic is taking up 2 bytes of space. Here, S would be a string slice that contains the first 4 bytes of a string. Earlier we mentioned that each of these characters is 2 bytes, which means S would be that? I don't know. If we were trying to slice only parts of a string byte, something like hello 01, Rust would panic at runtime in the same way as if an index value were accessed by a vector. What? Oh, okay. Rust would panic. I don't understand what that's saying, to be honest. Panic byte index 1 is not a char boundary. It is inside 3 bytes 0 to 2 of. Oh my god! So it does understand. It does understand the boundaries. It legitimately simply understands the boundaries. This is semantic nonsense. So it knows that you're not doing this correctly. When you ask for the 0, it knows that this takes 2. That this takes 2 separate things. It knows that. And it decides not to work with that anyway. Okay. We should use ranges to create string slices with caution, because doing so can crash your program. It only crashes because you've decided it should crash. Methods for iterating over strings. The best way to operate on pieces of strings is to be explicit about whether you want characters or bytes. For individual Unicode, it's pronounced zid, which reminds me of how in Super Smash Ness is named Heck. Oh yeah, Ness, Ness in Russian, even though it's pronounced Ness. I love that. I'm just gonna straight out call him Heck, man. That ain't changing. I love Cyrillic because it does stuff like this. That makes me happy just to see Heck. I mean, I know that the H character is N and the SS is the 2 C's are S's. But like, I just love that. That makes me happy to see Heck. Thank you for pointing that out. I had no idea that was a translation. Also, how do you Zida? I actually don't know how to pronounce that. That is so wild. I do love Cyrillic. I wish we had pretty characters like this. All ours are boring now. Right, so we have, so it's just dot chars, which I'm assuming will create an iterator, which we did talk about at a point. And then we just print out the chars. So why would you ever want... Right. Okay. And you can iterate over those. Can we also do the, what is it called? I'll never remember the name of that. Can we also go over the grapheme clusters? Can we go over the grapheme clusters? Can we just be like dot grapheme? Because it allows us to go over chars, it allows us to go over bytes. Alternative, you can go over the bytes, or all bytes, might be appropriate for your domain. Good stuff. Be sure to remember that valid Unicode scale values may be made up of more than one byte. Yep. Getting graphene clusters from strings, as with the Devinagri script, is complex, so this functionality is not provided in the standard library. Oh! Yeah, I remember how normal languages do this. It knows that you have to go over at 208. If it passes back 208, it should know that is not a letter. 208 is simply stating, go to the next byte. Follow along, go forward. It knows. It knows. This makes me legitimately angry. Why? What possible reason could they have for this other than to be able to use the word graphene clusters? I think that's it. I think they just really wanted to use the word graphene clusters because they learned it in English class. I hate these people. Maybe they should take English class because they don't know how to write. I mean, I might not know how to read, but at least I'm not using words like graphene clusters. Right, getting graphene... Yeah, if they actually want it, why not let us get the graphene cluster then? I'm sorry, I'm just ranting about this. If you want me to stop, I will, but like, this is probably useful for some things, but the average person would want to get just simply the characters, the graphene cluster, which would include these added onto the original character. Why not allow us to get the graphene clusters and instead only allow us to get the chars and the bytes? If the main reason why we're not passing back when we do an index like square bracket 0, we're not passing back the char, is because of this linguistic structure. Why? I see no real reason. Be sure to remember that valid. Yep. Getting graphene clusters from a string, as with the Divinity script, is complex, so this functionality is not provided in the standard library, but crates are available if this is the functionality you need. Okay, fine, be like that. What is the crate? What is the crate? Let me look at the crate. Nope. It doesn't suggest a crate. It's just like, hey, use this. Why? Because graphene clusters. That's a good point. Right. To summarize, strings are complicated. Different programming languages are different choices. Make different choices about how to represent this complexity to the programmer. Rust has chosen to make things difficult. Rust has chosen to make the correct handling of string data the default behavior for all Rust programs. This is just so bitchy, honestly. Okay, fine, the correct behavior, which means programmers have to put more thought into the handling of UTF data up front, which is something all programmers wanted to do. They all were like, you know what, UTF-8, too easy. We need more difficulty. Make this the Dark Souls of string concatenation, man. But it prevents you from having to handle errors involving non-ASCII characters later in your development lifecycle. No, it doesn't. The good news is that the standard library offers a lot of functionality built off of the string and reference string types to help handle these complex situations correctly. Unless it's in a language that utilizes some strange structure, some different structure, like in Devrangri. Oh my god, is this how French is stored? Is an acute accent stored like this? No, it can't be. Sure, whatever, maybe it is. Right, let's switch to something a bit less complex, hash maps. Okay, that's a good joke. I'm very happy that is a very good joke. Thank you for that. It is? That is how they're stored in French. Oh, that's how you type. Okay, that makes a little more sense, actually. I'll admit, I didn't know that. Usually when I use the French keyboard on my, Oh, okay. So you would just click E and then an acute accent? So it'd be like E, acute accent, E, obtuse accent. And that's how it would work, instead of just clicking like an E with the acute or obtuse accent on it. I didn't know that, actually. That's new news to me. Thank you for this information. Right, so in which statement is the best explanation for why? Oh, acute and then E. Okay. That is very, I wonder exactly why. That is good to know, though, yeah. String indexing. Indexing string is inefficient because strings are null terminated, so their length cannot be efficiently computed. That's definitely wrong. Indexing string is unsafe because how it can cause a segfault or buffer overflow. That is also true, but Rust will fix it for you in other ways. Indexing string would make Rust too easy to use, and Rust developers need job security. That's it! Oh yeah, I got that. I think this is the account you were on before. I think this is the correct answer, though. This is obviously the correct answer. Indexing string is ambiguous because string represents simple granularities of sequence data. This is what they want me to say, but this is the correct one. This is what is real. I'm going to answer correctly. I'm not going to fall for what they want me to type. Obviously. Obviously they know. They know. Too many people have complained about this, and they're making a joke in this quiz. Which statement best describes the difference between these types of string and string slices? Yeah. Right. Best describes the difference between the types of a string slice and a byte slice at U8. The reference string always points to data stored in the program binary, whereas that's wrong. U8 can be stored anywhere in memory. Reference string slice points to bytes that can always be interpreted as UTF-8, whereas reference UTF-8 can be any byte sequence. Reference string cannot be further sliced, while U8 can be sliced again, or reference string slice can be constructed from a string, while reference U8 can only come from a vec. I'll admit, I don't actually know which one of these is the most correct. Right, this or this is what I'm going for personally. I'm probably going to go with this. I think this might be the correct one. Yeah, because reference string would always be interpreted as UTF-8, whereas a reference U8... Wait, a U8, that's just an unsigned 8-bit integer. Yeah, that can be any... I'm sorry, I was thinking UTF-8 from this. No, a reference, bracketed U8, would be an index of type U8, which is a reference. I think this is correct. Right, I got one of the two correct. They're a line. This is a line. Secondarily, this is... Yep. Oh, I guess... Yep. So a reference string slice points to bytes that can always be... Yep. Let's see the correct answers. UTF-8 strings can be interpreted as a sequence of bytes, characters, or grapheme clusters. None of these is necessarily the default way of interpreting a string. Yeah, I'm sorry, but chars are the default way of storing string. That is just the default way. It's been that for decades. None of these are necessarily the default way of interpreting a string, so the default indexing operation does not make sense. I strongly disagree. You guys are making stuff up. I'm glad they at least gave me the correct answer here. Anyway, let's stop complaining and go on to... What? What is going on? Proving the Rust book. What is this? Yeah, we've already seen this. Why has it brought me back to this? Yeah, we gotta suffer! You know what? I'm into it. What is it? Tetanus? This is going to give me tetanus. Rust gives you tetanus. I understand and want to participate, I guess. Sure. I don't know why it showed me that again. Storing keys with associated values in hash maps. Oh, I love this. I'm very glad we are going over this. This seems to be about as large as the string thing. Alright, let's get in. The last of our common collections is the hash map. Type hash map stores a mapping of keys of type K to values of type V using a hashing function. Keys, value, pairs, which determines how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different name, such as hash, map, object, hash table, dictionary, or associative array, just to name a few. However, I should state, some of these, like object and associative array, will not in fact be a hash map in the background. Same with dictionary, but most of the time when you use a dictionary, it is a hash map. Yeah, hash map, aka hash or map. Thank you, Rustbook. You're very helpful. Hash maps are useful when you want to look up data, not by using an index. Not by using an index as you can with vectors, but using a key that can be any type. For example, in a game, keep track of each team's score in a hash map in which key is a team's name, and the values are each team's score. Given a team name, you can retrieve its score. We'll go over the basic API of hash maps in this section, but many more goodies are hiding in the functions defined on hashmap.kv by the standard library. As always, check the standard library documentation for more information. I should say, and you're going to get a lot of this during this is not really strongly my opinion, but just my personal experience and what I've read a lot about on. When you have a team of scores, you should probably be using a form of why have I forgotten the name? A struct, with just team A and team B with a value associated with each that you then change as the game goes on. A hash map includes a lot of information, a lot of work that needs to go into getting the key to a place in memory. There's a full-on function that turns letters into a pointer value. That can take a lot more time than simply accessing a pointer. So this specific thing here saying in a game, keeping track of each score as a hash map is not a great idea. That will be very slow comparably. But I can understand why you'd want it to be done in an associative array type of deal. Alright, creating a new hash map. One way to create an empty hash map is using new and adding elements with insert. In listing 820, we're keeping track of the scores of two teams. These names are blue and yellow. The blue team starts with 10 points and the yellow team starts with 50 because yellow is the superior color. Use standard collections hash map. Let mutable score equal hash map new. Scores.insert string from blue 10. So we have a simple string, which is the key. Then we have the value, which is 10. Same for yellow. And we have scores, which is the mutable hash map. Creating a new hash map and inserting some keys and values. Note that we need to first use a hash map in the collections portion of the standard library. Of our three common collections, this one is This one is the least often used, so it's not included in the features brought into scope automatically in the prelude. And it should remain that way. There are some very good reasons to use a hash map, but they are rare. Hash maps also have less support from the standard library. There's no built-in macro to construct them, for example. Just like vectors, hash map stores their data on the heap. I do like this. People tend to go for a hash map when they should not. Just like vectors, hash maps store their data on the heap. This hash map has this hash map has keys of type string and values of type I32. Like vectors, hash maps are homogeneous. All of the keys must have the same type as each other. All the values must have the same type. Accessing values in a hash map. We can get a value out of a hash map by providing its key to the get method as shown in listing 821. We have used it, brought it in. We have mutable score equals a new hash map. We bring in blue and yellow with 10 and 50 respectively. We have let team name equal string from blue. Team scores get from reference to the string here, dot copied, dot unwrap, or 0. Okay. So what we are doing here, I'm assuming, is we have the get method on scores, which is the hash map, which gets from a string, or a reference to a string, which may be coerced into a string slice. That will be blue. Then we dot copied. I don't know what this does, to be entirely honest. And then we unwrap it, because copied could return an option. It could exist or it could not. Like if that was bluey or like green, it could just not exist. So we unwrap it or 0. If we have a none value, I'm assuming the underscore or allows us to just pass in 0. Here, score will have the value that's associated with the blue team, and the result will be 10. Get method returns an option with a type of vector. So there's no, sorry, I don't know what that is. If there's no value for that key in the hash map, get will return none. If there's no value in that key for the hash map, get will return none. This program handles the option by calling copy to an option I32 rather than an option reference I32. Then unwrap or to set score to 0 if score doesn't have an entry for the key. We can iterate over each key/value pair in a hash map in a similar manner as we do with vectors, using a for loop. Okay, we have 4 key value in reference scores, prints out the key and value. The rest of this is the same as before. It's good to know? Good to know? Okay, so I'm kind of curious where all this is stored. Like, oh man, I've never actually seen somebody just go over all of the values in a hash map. That could just be weirdness with my experience though. The code will print each pair in an arbitrary order. Yellow, 50, blue, 10. Yep. Hash maps and ownership. For types that implement the copy trait, like I32, the values are copied into the hash map. For own values like string, the values will be moved, and the hash map will be the owner of those values. That's demonstrated in listing 822. Right, so we have field name and field value, favorite blue. That mutable map equal hash map new, insert the field name and field value. So here, the field name and the field value no longer have ownership. Ownership is consumed by the map, or the hash map. Field name and field values are invalid at this point. Try using them and see what the compiler gives you. Let's try running this. No output. Thank you. I'm sorry, I'm too tired to go and put this in. I'm assuming I was just going to say something like, doesn't implement the border trade. Sorry, no. I assume that it will simply say that it is invalid at this point, or whatever you get when you normally do this type of stuff. Cannot remember. Wow, very descriptive. You're welcome, guys. We aren't able to use the variables field name and field value after they've moved into the hash map with the call to insert. If we insert references to values into the hash map, values won't be moved into the hash map. The values that the references point to must be valid for at least as long as the hash map is valid. Talk about these issues in Validating References with Lifetime section in Chapter 10, coming up close. Updating a hash map. Though the number of key and value pairs is growable, each unique key can only have one value associated with it at a time, and not vice versa. Vice versa. For example, both the blue team and the yellow team could have value 10 stored in the scores hash map. Sorry. When you want to change the data in a hash map, you have to decide how to handle the case when a key already has a value assigned. You replace the older value with the new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value. Or you can combine the old value and the new value. Let's look at how to do each of these. Overriding a value. If we insert a key and a value into a hash map and then insert that same key with a different value, the value associated with the key will be replaced. Even though the code in listing 823 calls insert twice, the hash map will only contain one key value pair, because we're inserting the value for the blue team's key both times. So we have, what did this run? 10 and 25. When we insert the second time, it's just going to overwrite. Good to know. Replacing a value stored with a particular key. This code will print blue 25. The original value of 10 has been overwritten. I wonder what happens to ownership. Like, if this was a variable itself, will the variable regain ownership? Or will it just be kind of in this weird limbo? Adding a key and value only if a key isn't present. It's common to check whether a particular key already exists in the hash map with a value, then take the following action. If the key does exist in the hash map, the existing value should remain the way it is. If the key doesn't exist, insert it and a value for it. Hash maps has a special API for this called entry that takes the key you want and want to check as a parameter. The return value of the entry method is an enum called entry that represents a value that might or might not exist. Let's say we want to check whether the value for yellow team has a value associated with it. If it doesn't, we want to insert the value 50, and the same for blue team. Using the entry API, the code looks like this. Alright, so we have scores.entry. We are trying to add in something to yellow, or insert 50. So if it exists, if the key exists, yellow, we do nothing. If it doesn't, we insert 50. So this is a method being called on. Secondarily, since blue exists, it'll hit here, entry, string from blue. It'll check if blue exists. Blue does exist. That means that blue will remain 10 instead of the 50. So we'll have yellow with 50 and blue with 10. Let's check. Yep, blue will remain 10. The entry just takes in a string that says, hey, this is the key I want. You can then run the or insert 50 method if you want to insert some, if it doesn't exist. The or insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists, and if not, inserts the parameter as the new value for the key and returns a mutable reference to the new value. The technique is much cleaner than writing the logic ourselves and, in addition, plays more nicely with the borrow checker. Running a code in listing 824 will print yellow 50, blue 10. The first call to entry will insert the key for the yellow team with the value of 50 because yellow team doesn't have a value already. The second call to entry will not change the hash map because the blue team already has a value of 10. Updating a value based on the old value. Another common use case for hash maps is to look up a key's value and then update it based on the old value. For example, listing 825 shows the code that counts how many times each word appears in some text. We use a hash map for the words as keys and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen that word, we'll insert 0. The value 0. Right, standard collection hash map, text hello world, wonderful world. We have mutable map, hash map. For word in text.split white space, just creating a just splitting this up into hello world, wonderful world. That count equal map.entry word or insert 0. Take count out plus equals 1. Okay, so every time this goes through, we'll create the count variable. We'll have it equal map.entry word or insert 0, which will, if it exists, if the word exists, so if hello exists, it'll pass back a reference to the hash value called hello. I guess in this time, it would be world. If that does exist, count will equal a reference to world. Count will equal a reference to the hash map entry under world. And thus, we can plus equal 1 to it. So in this case, we go from hello. It would check if hello exists. It does not. So it would insert 0. Then it would go to world. World does not exist. So it would insert 0. Wonderful. Wonderful does not exist. Enter 0. World does exist. We do not do the or insert. we pass back a reference to the hash map value, sorry, the hash map key world's value. We have count plus 1. So in the end, we will have 1, 2, 3 different keys in the hash map. And this will equal 0, this will equal 1, and this will equal 0. Let's just check that. Sorry if it's hard to really... Oh, sorry, yeah, I guess that'll be 0 because we will always just plus equals 1. Yep, so that'll be 1, 1, and 2 for world. Counting occurrences of a word using hash maps, stores, yep. This code will print world 2, hello, 1, wonderful, 1. You might see the same key/value pairs printed in a different order. Yep. Recall from accessing values in a hash map section that iterating over hash map happens in an arbitrary order. So it will not always give us back this order. We don't know what order it will give us back in because we don't know where in memory it's held. What it's likely doing is it's just taking a contiguous piece of memory which all of these things are held into, and it's just going over each bit by its boundaries. Alright. The split whitespace method returns an iterator over subslices separated by whitespace. We got that of the value in text. Or the OR insert method returns a mutable reference to, at mut v, to the value for the separated key. Okay, so v capital is simply the value in a hash map. Here we store that multiple reference in the count variable. So in order to assign to that value, we must first dereference count using the asterisk. The immutable reference goes out of scope at the end of the for loop. So all of these changes are safe and allowed by the borrowing rules. Okay, yeah, makes a lot of sense to me. Hashing functions. By default, HashMap uses a hashing function called SIPHash that can provide resistance to denial of service attacks involving hash tables. Here's a reference to SIPHash. Here we are. Yep, that's just the wiki for SIPHash. This is not the fastest hashing algorithm available, but the trade-off for better security comes with the drop in performance is worth it. If you profile your code and find that the default hash function is too slow for your purposes, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. We'll talk about traits now to implement them in Chapter 10 quite soon. You don't necessarily have to implement your own hash from scratch. Crates.io has libraries shared by other Rust users to provide hashing implementations, many common hashing algorithms use. Right. On top of this, really, you can just use arrays or vectors. For the vast majority of this, arrays, vectors, simple structs, even enums can be used for all of this stuff. People tend to jump to hash maps, every single time. You see them in places all the time where they definitely do not need to be. As it is stating here, it is quite slow for one, and for two, this is only resistant to denial of service attacks involving hash tables. Only resistant, meaning you can still utilize denial of service attacks involving hash tables. And if you go for a quicker hash table, you still have the same issues. Structs, vectors, and arrays do not have the same issues. Well, don't have as common of issues as this does. I don't know if anybody's listening to me right now when I say this, or if I'm just speaking to the choir. People already know this really well. Hash maps, you need to have a when you want to use a hash map, you need to have proof that your hash map is a good thing to use. You can't just use it because it's convenient. It's the type of thing you use only if you know what it's doing and that it is necessary in this point of time, or is much quicker, and you have some proof of that. Determine whether the program will pass the compiler. If it passes, write the expected output as if the program were executed. Use standard collection hash map. Function main, we have mutable hash map new, HW insert K1 at position, with value 0. We have V2. Right, if this can pass the compiler, what do we see that's wrong with this? Right, so we are just creating a new hash map. That's fine. We have h dot insert k1 with value 0. We have v1, which equals reference to h with the value of k1. Can we do that? Can we get a reference out of that? I don't think it even discussed that. I'm going to assume that's fine. However, I don't really know. Yeah, I'm certain that's fine. h.insert. Right, so we have a reference here. I don't think this will compile, because we have a reference here and are then mutating. We are mutating the hash map when we have a reference outside of it. I mean, I don't see why that would be an issue with Rust, because a hash map shouldn't matter if you insert new things into it, as long as you're not altering the original thing here. I'm going to say no, because the issue is that we are borrowing part of the hash map here with v1, and then we are attempting to mutate hash map here. That shouldn't be an issue, really. But I think Rust might see this as an issue. Let's submit the square and go on to the next one. Oh, you don't see why that? Yeah, I should have... Sorry. I'm going to say Rust thinks that's an issue. That's what I'm trying to say. If I'm proven wrong, it will make a lot of sense. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. We have a standard collection hash map at mutable h equal of type hash map char vector type usize for I and C. Hello world that char is enumerate. Alright, so we got HELLO and exclamation mark for I, which is the index, and C, which is the char. H.entry C or insert vector new push I. Right, so if the letter exists, if the letter does not exist, insert a new vector, the index inside of it. Okay. So that'll be 1, 2, 3, 4 different elements inside of the hash map. Each one will have their index in it, but L will not have this index in it at all, I believe. Right. Let mutable sum equal 0 for I and h.get L.unwrap. I think that's fine. Sum plus equals dereference I. Sum. Right. I think that there's only going to be one L here, right? I don't see any issue with this compiling. But there will be only... Well, there will of course be only one. Or insert. So if it does exist, I might be forgetting. Entry. Is entry the one where it checks if it exists? If it doesn't, it does the or insert. But if it does nothing, in which case this will simply be 2. Yeah, I think that this is just 2. I'd be surprised if it wasn't 2. Because this will not run. It'll see that L already exists, and since it does, it won't run this. It will not create a new vector, at which point it will not push I. And this is perfectly fine, because this is just getting you a vector, which you're then running over the one instance of it inside of there. That's 2. I think that's just 2. Right, we got one of these correct. This does not compile. Okay, so we were wrong. I'll be very clear. I was wrong. I thought that there was no issue in this, but I think Rust... Right. What is Rust's issue in this? H cannot be mutated. H.insert K2 while an immutable reference V1 to it is live. Okay, so that is the issue. Rust does not like this, even though I and you really don't see any issue with this working. I wish that it described what reasoning it has for that. Because I don't see any issue with you mutating a different part of a hash map. I don't see the reasoning for that. Determine what the program will pass the compiler. If it passes, right, this does compile, but the output of the program will be 5. Okay, so I was wrong. The program stores a vector of indices for each occurrence of a given letter in a hash map. Okay, so it does. That would be 2 and 3 for the L's in hello. So I was wrong with entry? What was I thinking of? What was I thinking of? Adding a key and value only if a key isn't present. Hash maps have a special API for this called entry. It takes the key you want to check as a parameter. The return value of the entry method is an enum called entry. Yeah? So why does this work? Okay, I am confused here. By my understanding, entry should only work if the L does not exist. Right? That's what it's stating here. So here we have blue. Score entry. Blue. Blue is inserted here with a value of 10. At which point we get to here, we have string from blue, or insert 50. It does not insert 50. Does not insert 50. Because blue does exist. Oh my lord. Okay, I see what I did wrong here. Right. I understand now. Right, let's just, Right, so here's the issue. I didn't see this bracket. If we look here, this bracket ends here. Right, that's my issue. Just to show you guys my shame. I thought it was this. So we would have a vector, which is created, and then we will push I to it. That's what I thought we were doing. And then it would not run or insert in any case. But the bracket is here, thus it will either A, insert the vector new, or B, return back the original hash map entry, the value. To which, so either way it'll push back the new vector, or the old vector that was created previously. And we will push the I value. So in either case, it will push the I value. I see my issue here. I missed a single one of these. I didn't look too deeply at scope. That is my issue. That was my problem. I missed the bracket. Alright, that's fine though. Right, summary. Vector strings and hash map will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Given a list of integers, use a vector and return the median. When sorted, the value in the middle position and mode, the value that occurs most often. A hash map will be helpful here, of the list. Okay, convert strings to Pig Latin. The first consonant of each word is moved to the end of the word, and I is added. So first becomes first by. Words that start with a vowel have hey added to the end of. Yeah, we get it. Hash maps would not be good for a game inventory. I mean, from a regular standpoint, kinda. Like, well, not at all. Like, let's say you have 30 object holes in which you can put in a specific item with a value. Right there, we'd need an array of 30 holes, in which case a struct with the name, amount, description, and uses will be placed in. A hash map would be a terrible idea for a game inventory. how would you access them all? How would you list them all out? Well, of course you could do it in just like, hey, pass this all out, but it would be in a random order, right? So if every time you opened up your game inventory, everything was randomly sorted, that would be a pretty bad experience, right? Unless A, you implemented some separate sorting algorithm, or B, you sorted it by like alphabetical order, it would look really weird to a person looking at your inventory. That's one issue of it. Secondarily, it would take up a lot of time for you to get every object out of that and to access any specific object. A game inventory would be a terrible use for a hash map. Really, I doubt that you're going to find many good uses for a hash map in your programming experience. I'm sorry to say, especially when it comes to games, unless you're getting into really like algorithmic heavy stuff. Using to create a text interface to allow user to add employee name to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let the user achieve a list of all people in the department or let all people in the company by department sorted alphabetically. Alright, so I'm just going to say again, all three of these, really you shouldn't be using hash maps. I'm sorry to say, they're not useful for any of these. These are just things to get used to hash maps, like the random, generic things used to, you use dictionaries in Python in order to replace match statements. Yeah. A lot of people will suggest hash maps, and this is something I really want to harken on. I want to just continually state this. Most of the time when people use hash maps, it's the wrong thing to use and can cause a lot of issues down the line. But if dictionaries allow for reasonable use of match statements and allow for a better personal experience, that's perfectly fine. I'm not saying like you're dumb or wrong for using the things you use, just saying that there are other better ways to use these things. And also separately, you really shouldn't be if you don't have any actual like real reason to use a hash map and a hashing algorithm. It'll just be slow and meaningless, while adding really nothing to it. Standard libraries. The standard library API documentation describes methods that vector, strings, and hash maps have that will be helpful for these exercises. We're getting into more complex programs in which operations can fail, so it's a perfect time to discuss error handling. We'll do that next. Your code was spaghetti back then? I love spaghetti though. Delicious. Gorgeous food. Trust me, man. Some of the most spaghetti code you'll see is in like the biggest things. Seriously, you go into like Google or like Microsoft Windows or something like that, some of the biggest, most complex industries ever, you're gonna find spaghetti to beat all spaghetti, man. It would make an Italian man cry. Terrible time. Terrible situation. Anyway, though. Oh, we have ownership inventory. Number 2. After this, I think we're done. Like a bunch of if statement spaghetti. Oh, it cannot be the worst that you've ever seen. Have you ever seen, God, what is his name? Sundere Dev? I can't remember the guy's name. Terrible code, man. But we all do it. Right, so here are 6 questions which we can do. You try to compile this function? Which of the following best describes the compiler error you would get? God, I am too tired for this stuff. Removes all the zeros in place from a vector of integers. Remove 0. Takes a mutable vector. For I, t, in v.iter, enumerate. Reverse. Why? If dereferencing t equals 0, v.remove I. Okay, so we have a v.shrink to fit. Yeah, why? There's no reason. Shrinks the capacity of the vector as much as possible. It will drop down as close as possible to length, but vectors may still... Right, so what is the problem with this? v.remove I cannot borrow v as mutable. Right, v is a mutable reference to vector I32. So yes, we can borrow v as mutable. I believe. I don't see why we couldn't. Unless this is something that I've forgotten that we have to, like, make it mutable in the for loop or something like that. Because, oh, yeah, because t is alive. T is a immutable reference to the value in v. So we can't actually remove it here. Oh, yeah, that is the issue, I believe. T cannot dereference while I is still alive. Maybe that's actually the issue. No, T can be dereferenced, that's fine. V does not live long enough to call v.remove1. That's incorrect. v.iter cannot be called on a mutable reference. I believe that it can. Right, so I think that the real issue here is that remove I cannot borrow v as mutable. Because here we are creating a reference, an immutable reference, to the specific value. Here, we are trying to mutate v. But v needs to exist for t to exist. So we can't actually do that. We can't do that. Especially not here. I believe this is the issue. Right. Question 2. Normally, if you try and compile this program, the compiler error is the following. Ah, yeah, here it's one of those things where the next question literally answers the previous question. Cannot borrow reference v. Hello, sorry for bothering you. However, I want to be banned. How do I ban you? How do I ban you? I'm going to report you. Delete message, timeout, ban. Oh, that's how you do it, but I'm going to report you first. We are reporting terrorism. Spam, scams, or bots. Next, this is bots and a spam. Closing line. Nope, it's bots. Next. Sorry for this. Came in and started advertising. Submit report. Journal error. Thank you, Twitch. That's really good. I'm not going through that again. We're just going to ban. We are going to ban. Unable to ban user. What the fuck is going on? Whatever, man. You know what? Fine. I guess he's here. He's allowed to be here. We love him. He is our friend now. I'm going to go and give him large quantities of money. Anyway, the error here was cannot borrow reference v as mutable because it also borrowed as immutable. Assume that the compiler didn't match if any of these show them ownership. Oh no. We don't want them to die. We don't want to hurt them. We don't want to hurt them, Sorbet. Look, they may be bad, but I wouldn't wish that on their worst enemy. No. You're going too far. That's against the Geneva Convention, you know? Alright, what would cause error? So if we brought this in, the vector 1, 2, 0, and 3, remove zeros, or 5, 5, 0, or 1 to 100. Remove. Which one would cause an error? Right, so we have 0, that removes here, and we shrink to fit, and then we go back over. Eventually, we will get to the end. Oh, eventually, I will be larger than the vector, because that won't change, right? So we have an iterator here, which will go 0. Here will cause an issue. 1, 2, 3, 4. So we have 4 different sections. 0, 1, 2, and 3. It'll go through 0, 1, 2, at which 0, 1, 2, at which point it'll remove 1 because it's 0. And when it hits 3, it'll try and access t, even though it's not on the same spot. That'll be a use after free. This will be an issue. I believe that's an issue. Perhaps not. Secondarily, we have here where we remove the zeros and attempt to print v. Since that's shrunk to fit, I don't think this is going to cause an issue. It'll delete that 0, it'll shrink this array to 5, 5, and then it'll use v. I don't think that's an issue. Secondarily, we have 1 to 100, which will literally do nothing. It'll do nothing. This will always fail. I think this is the only place where any issues are in existence. Unless I am wrong. Well, of course, unless I'm wrong. Alright, let's reread this error just to recheck. Cannot borrow reference v as immutable, because it is also borrowed as immutable. That happens here. Mutable borrow here. Mutable borrow occurs here. Right, v.remove is the mutable borrow. Here is where the issue would exist. Right, I'm just going to say here. Okay. Question 3. Of which of the fixes highlighted yellow would best satisfy the 3 criteria? The fix function passes the rest compiler, this function preserves the original code, and fix function does not introduce unnecessary inefficiency. Right, so we have for I in 0.v.length.reverse. I don't see why we reverse. There's no reason to reverse. Are all of these going to reverse? Yeah, all of these are going to reverse. I don't know why. No. Right, so we have I in a range, which allows us, that's no longer mutably borrowing. We have if vi is equal to 0. Yeah, I think this is fine. This, I think, is the best. This, so this just creates a range, no longer mutably borrowing. We're no longer borrowing anything for v originally. And then we remove it and shrink it. We're just checking for something here. Right, this still borrows it and changes nothing here, but it brings in a vector of I32s. I don't think that's a great idea. This one returns a vector of I32s and creates a new mutable vector here, which then pushes to... Okay, so this does actually solve the error originally, but it also creates a new vector which would be an inefficiency. I don't think this is the correct solution. Also, separately, this is created here and then returned here, not even as a reference, or I guess that would be cloned? But that would be destroyed originally, so I don't think that's going to work at all. Secondarily, we clone it here, which would work. I believe that would work. That wouldn't have an issue. This would pass the compiler, but here's some inefficiency in the clone. I believe that this is the best answer. Alright, question 4. If you try to compile this program, which of the following best describe the compiler error you will get? We have reverse. We bring in a vector, which is a mutable reference. Let n equal v.length. Right, so that's just length for I in... Right, so for half of them, standard memory swap. Okay, we have... Right, so we just swap the memory within a mutable reference to v, and a mutable, to the mutable reference to the first object. Right, so for the first half, we go 1 by 1 by 1, and then switch it with the length of it minus the index, starting at 0, so that would be the last element, then the element before. Right. Try to compile this program, which error would we get? Cannot borrow v as mutable twice for v1 and v here. I think this is the issue, because we are borrowing it as mutable twice. Cannot mutably borrow an element of vi of a mutable vector. I think you can. Cannot borrow v as immutable for v.length when v is a mutable borrow. Yeah, you can. So I think this is the actual issue. Right. Now I believe it cannot borrow reference v as mutable more than once at a time. Yep, so we were right about that. Or I was right about that. Sorry, I didn't really get your input on that. Right. Assume that the compiler did not reject this function. Which, if any, of the following program would 1. Pass the compiler, and 2. Possibly cause undefined behavior of X? Right. Mutable v equals vector string from A, string from B. Right, so we have two strings in a vector. Reverse mutable v. What this would do is yippee, yeah, we win. Right, so A and B would be swapped. I don't see any issue with that. A string from B, and then we use it. Okay, so... Oh, I think this will be the issue. Right, so here we simply have A and B, which will be swapped. We have B and A. Now, I see no issue with that. Anyway, that could cause an issue. Then V is passed out. We have mutable V, vector from A, B, and then we don't use it. Then we have mutable vector A, B, simply passed in, that's BA. We then let X equal a reference V, a reference to the 0th element of the vector. So that will be A at this point in time. We then reverse it, reversing the memory. I think this will be the one that causes an issue, if anything, but I really don't think this will be undefined behavior. And 2, possibly cause undefined behavior if executed. I don't think this will cause undefined behavior. Right, so if A is now in the memory address, as said here, because standard memswap will simply swap out the memory. The pointer stays the same, I'm pretty certain, right? You want to take a swaps the value between two mutable locations without deinitializing either one. If you want to swap a default or dummy value, see take. If you want to swap with a past value, returning the old value, see replace. Alright, yeah. Alright, so we have let mutable x equal 5, let mutable y equal 43, 2, assert equal, 42 equal x. Yep, so I think that none. Honestly, I think none is the answer here. I mean, I understand that there is. Does swap work by doing both C equals A equals B, and then back to B equals C? Yes, I'm certain that has to be how it works in the backend. I mean, it has to store it in a separate location. You are correct. It does have to store it into a separate location in order to get any of this to work. That's almost certainly what the backend is doing. Oh, thank you for that input. Still, though, I really don't think any of these cause undefined behavior. I would be fairly surprised to find that out. Unless it's something like this is destroyed at this point in time because of... So, if so, yeah, no, it doesn't work. Why wouldn't it work? If it brings back... I'm sorry, I really don't understand why it wouldn't work in that point. This could just be my own stupidity. That sounded really mean. I am incredibly tired, so I might be missing something obvious here. Right. Well, this is the second to last question. I'm just going to say none of these programs will cause any issues. For now, at the very least, we'll get a description at the end of why. Right, lastly, reverse the elements of a vector in place. God, I am tired. Of the following fixes highlighted in yellow, which best satisfies these three criteria? The fixed function passes the rest compile, the fixed function preserves the intended use, and does not introduce unnecessary inefficiencies. Okay, right, so we have let P1 equal immutable reference to VI as the reference mute string. Honestly, we both have about the same, or well, if anything, I have about the same possibility of being wrong as you. You seem to have thought through it a little bit more than me, though, sadly, on my end. Alright, so we just have, we have unsafe here. Well, I mean, yeah, if we just use unsafe, it'll work. I don't know what bytes between the two regions of memory beginning at X and Y. The two regions must not overlap. Behavior is undefined and the following connections are violated. Both X and Y must be valid for both reads and writes. Yep, okay. I don't think that's going to be the right thing, because why would you use an unsafe method here? Right, reverse and v.length mutable v equals v.clone. I don't think this will work. Right, so that'll go from the first start all the way to half up and take values from the secondary clone and put it into the front. So you'll have the first half be just the clone of the second half. The second half will just be what it was before. That doesn't do what we want it to do. Right here we have S1 equals v index.clone. Right, so we clone S1 and S2 equals. Right, so the first half we go through that. This is a clone. This is the last one .clone. And here we have vi equals S2. And the okay, so we take the first section and the last section and then clone them into new pieces of memory. And then we take the original and we mutate it, taking an S2 as the first value, S1 as the second value, or the last value. I think that is correct, honestly. I think that's the best. Right. So here we return a new string, take in a reference to a vector string, and return a vector string. This is non-idiomatic. This is not supposed to reverse. This is supposed to reverse in place. So that cannot work because this is not in place. I think that this is the best solution because it does it in place in an idiomatic way that is easy to understand and does not use unsafe code, which would be an added inefficiency. This doesn't do anything. Do you have any thoughts on that? This is the last thing, and the last thing we'll be doing today before going over all of our failures, or my failures really on a lot of these. Unless you want to add anything, I think I'm just going to go with this one. This one makes the most sense, it's the most readable, it's the most understandable, it's the one that doesn't use unsafe code, especially not standard pointer, swap, none over. I don't know what that does. Both X and Y must be valid for the reads and writes. Both X and Y must be properly aligned. And the reason memory. Note that even if the effectively copy size pointers must be on prime. You are confused? Makes sense. I didn't explain this very well, did I? Right, so we're just looking for the thing that passes the compiler, preserves the intended functionality, and does not introduce unnecessary inefficiencies. What we are trying to do is we are trying to reverse a list. So we have 0, 1, 2, 3, 4. We want that to be 4, 3, 2, 1, 0 at the end. And we want to do it in place. So we pass in this vector. We want this vector to change. So here, we have two different variables. The first half of it, so 0, 1, 2. We go over A. We want P1 to equal the first variable, P2 to equal the last variable, and in unsafe code, we swap the memory between the two. We swap the pointers between the two. We swap the pointers. We swap the reference. So we simply take these things and we swap them. That would work, but it's very inefficient. Secondarily, we get the length of the vector, create a new thing, which is mutable, v2, and clone it. We just copy over the original vector into a new separate vector. And then for the first half of it, we swap out the first element, or the element that we want, 1, 2, 3, 4, 5, so on, with the last element, 5, 4, 3, 2, 1, so on and so forth. from the new vector. So if this was 1, 2, 3, 4, 5, 6, we would go 6, 5, 4, 4, 5, 6. That's not really what we want, is it? Yeah, I'm not explaining this very well, am I? I don't think I really can, to be honest. Not without being able to ask questions in conversation. I am sorry about that. I completely understand the confusion, however. This is not too easy to follow without thinking it through yourself and perhaps coding a little bit of it. Yeah, that makes sense that you're confused. Anyway, I think I am just going to answer this and go through. Oh, you understand now? Okay. Or was I just explaining it to you when you understood it originally? Ah, sorry for that if so. I got more questions right than I thought I would. I thought this was going to be 1 in 6. Honestly, that's what I thought. I'm proud of myself. In Canada, that's a passing grade. Or at least in Nova Scotia. I don't know if the French are any different. Maybe they're more harsh on their students. Maybe they should be. But here we are. I guess we technically passed. Right, so we got this correct. This cannot borrow as immutable. I cannot borrow V as immutable. I think I pressed that one, but I guess I did. Makes sense. Question 2. Got this one incorrect. This one is a failure. Alright, what was the issue? Assume the compiler did not reject this function. Let's just get the answers. Oh, that's what I thought was incorrect. However, we missed one. This one is also incorrect. Makes sense. Because that's literally the same code, but this one uses it at a different point. I feel dumb. In French, you can fail your exam for not using the right gender for a chair. Oh my god. Yeah, I forgot that French was a gendered language. I've never been able to understand that. I am sorry that's what you've had to deal with as a kid. I would rage if that was the case, honestly. I don't think I would have passed high school. Okay, so here is my own stupidity. Oh, no, I can understand why I thought that. Right, to violate memory safety, remove zeros must be called with a vector that contains a 0 after the first element. The call v.shrinktofit will deallocate memory owned by the vector due to resizing, which will invalidate the iterator v.iter. Contains a pointer to old data. Oh! Okay, that's the issue. Which will invalidate the iterator v.iter, which contains a pointer to the old data. Note that reading the vector v after calling remove zeros is not essential to the safety violation, since the issue is internal to remove zeros. So the issue is here. v.iter.enumerate rev I. I is a reference to something that is now destroyed. Okay. Yeah, I wasn't even looking at that section. Let's reread this just to get it in my head. The call to v.shrinktofit will deallocate memory owned by the vector due to resizing, which will invalidate the iterator v.iter, which contains a pointer to the old data, at which point it will be used for the iterator. Note that reading the vector v is not actually part of the violation, though that would violate if this was not an issue. That's not essential to the current safety violation. Okay. Question 3, we did get right. Question 3 was this one about A, of the highlight effects which best satisfies the 3 criteria. Right, let's read the context on this. Any strategy that requires allocating a new vector either via veclone or vecnew requires unnecessary additional allocation. That is correct. Therefore, the simplest strategy that works is to only iterate over the indices 0 to the length, which does not borrow v. We do this in reverse order to avoid missing indexes. What? Oh, I see. That explains the reverse. I can understand now. Right, so if we went 0, 1, 2, 3, and then 3 was destroyed, we would go 4 would be put into where 3 was. Cannot see my hands. Right, so if we were to go, and this is just for me, you probably understand this right now. If we go 1, 2, 3, 4, 5, 6. So we go from 1. Right, so we go over here, and we are trying to delete 3. We start with the first index, 1. And we see 1 is correct. That's fine. That's not 3. We are not deleting it. Go to 2. 2 is correct. 2 is not 3. We are not deleting it. Go to 3. 3 is 3. We delete it. Now go to 4. And 5. 4 at no point is 4 checked to see if 4 is 3. Say this is 3. So we have 2 3s. So go over this again. We start with the first one. This is the indices. We will check if it's 3. It is not 3, and thus we add 1 to the index. The index is now 2. We are checking the second element of this array. So on and so forth. When we reach here, we will delete 1 and move on without rechecking this point. However, if we do this in reverse, we will always be checking the correct one. 6, 5, 4, that is 3. 3, that is 3. 2, 1. Yeah. That makes a lot of sense. I should not have saved that. This is not needed. Okay. Like with problem 1, the most idiomatic strategy is actually use a built-in function we have discussed, vec retain. I did not read that. I didn't read this. Immediately borrows. Yeah. Okay. Yeah, I didn't read that. Anyway. The most idiomatic solution is vec retain. This function keeps only elements in a vector that pass a predicate, but does so with more memory efficiency. Okay. So vec retain is simply like you pass in something you don't want to exist and it eats it all out. Yeah, okay, so here we go. It would say, hey, vec retain. I can't remember what this is. I think we've discussed this before. Referenced x. Oh, referenced x, that would equal a new variable called x. X mod 2 is equal to 0. So every odd number. We want to delete every odd number. So this will go through and check every single piece, see if it's odd, eat it out if so. So instead of running over everything in a for loop, which is not a great idea, we have a built-in called retain, which we can just, hey, anything which passes this, delete it. Or passes this, keep it. Right, question 5. We got right. None of these programs. I am surprised. Yeah, so none of those programs were a failure. None of them broke. This function cannot cause a memory safety violation because I does not equal n minus 1 minus 1 for all I. So the two mutable references always refer to different elements. Note that let x equal $v 0 program would not compile, as Rust Burrow Checker would not allow reverse to be called while x is live. Okay. Question 6, I did get wrong. I answered this one. The correct answer is an entirely different one. It's the one with unsafe code. Alright, so the correct answer was the one with unsafe code. That's apparently the most idiomatic. I guess we are cloning, which is inefficient. Okay, fine. Let's read why. In a situation where the Burrow checker rejects an operation that is actually safe and has no workaround, then unsafe code is sometimes acceptable if it's critical to avoid allocation. In this specific case, you should actually use vec swap, which is internally implemented with heavily tested unsafe code, similar to the code above. But in general, the standard library doesn't happen to support your use case, then unsafe can be acceptable if used correctly. I guess that's really what it's trying to beat into our head. In the previous question, we did answer correctly. None of the programs caused an issue. None of them actually would have caused undefined behavior. So hey, if nothing can cause undefined behavior, why not just say, hey, I know this is fine. I know this has 0 issues. Do as I say. The issue here that caught me, I guess, is swap non-overlapping, I guess. Because we hadn't seen that before. But that does make sense. I guess that's good to beat into your head. Sometimes unsafe is fine. As long as you have a use case that you are certain will not have an issue. So I'll admit, I will not be confident enough in this situation to do that. I'd have to find somebody else who's confident enough to state that this is a reasonable thing to do. But okay. Next session is error handling. I am quite happy with this. I'm good to see error handling. It's going to be quite small, it looks like. But we're nearly halfway through, it looks. Yeah, we are nearly halfway through. I'd like to thank you for being here, Sorbet. I really do enjoy your company while reading through this. It's great to have somebody else to watch my stupidity and correct some of my errors. Give their own point of view. Yeah? Ask Noah. That's actually a good idea. Anytime we think unsafe code might be a good idea, ask Noah. I'll get him on fucking speed. But yeah, thank you again for being here. I am going to leave, however. I'll see you soon. Talk to you later about the CLI.ff-ff.